Smart contract developers, welcome back to yet another exciting tutorial. In this tutorial, a smart contract development tutorial, we will build a token staking smart contract. We'll build an entire from scratch. We'll test it and we'll deploy it on Rootstock test network. And those who don't know what is Rootstock, you can go to rootstock.io and there you can find all the documentation you need to know as a developer, as a smart contract developer, as a full stack blockchain developer. On Rootstock you can build different type of DApps, DeFi, tokenization, NFT marketplaces, and so on. So in this tutorial we are going to build token staking, where we will build a mintable staking token first, and we will create a staking contract where we will add stake, withdraw, and earn rewards functionalities, write comprehensive test suits to test our smart contract rigorously, and we'll write deployment script, and we will also add like advanced functionalities like emergency pass and minimum stake, reward distribution, and we'll give some access to owner only, right? So in this tutorial we are going to use Foundry. So make sure you have installed Foundry. Those who don't know how to install, just go to getfoundry.sh/introduction/installation. They have updated documentation. You can see a couple of days ago they released the new documentation. They updated and it is so beautiful. I'm just loving it. Also make sure you have added install MetaMask extension and add it to your browser. Also inside the MetaMask extension, make sure you have added the rootstock mainnet and testnet. We are going to deploy our smart contract on testnet, but also make sure you have added rootstock testnet as well. So inside the testnet, make sure you have rootstock faucets in order to deploy smart contract. You can go here, faucet.rootstock.io. I just received successfully some RBTC to deploy. To get this, you can just go copy your address, paste it here, and check you are not robot, and just click this button, get test RBTC, and you will receive. I just received, so I will receive again in 24 hours. So also make sure you those who don't know how to add this rootstock testnet or the rootstock mainnet to your MetaMask, just go to rootstock.io, and inside that they have comprehensive documentation. Go to documentation, and inside here in search bar you can search over here. It is loading, just wait. And I have already searched the MetaMask over here, so you can also search, and you can see 3 tagged with MetaMask. Configure MetaMask wallet for rootstock, and here you will find 2 buttons. From here you can easily add these 2 networks to your MetaMask wallet. So I already added, you can see rootstock testnet and rootstock mainnet, so you can add from here. So if you want to learn more about the rootstock and its high level concept, and along with documentation, they have really great written docs as well, where you can learn about POPEG, really interesting stuff to learn about Bitcoin and rootstock, the merge mining, how rootstock merge mine with also you can explore RBTC ecosystem, how to get RBTC and trade, what are the supported wallets, and what is the rootstock roadmap. Also they have rootstock also sponsor hackathons, and they give away huge prizes to the true builders of Bitcoin. So you can find their upcoming event just to participate in hackathons and their meetups. Here you can find inside the events. And also they have ambassador program where you can contribute to rootstock ecosystem and earn some reward. And they have also blog where you can learn and educate yourself about rootstock. And if you go to docs, they have really great program ongoing, rootstock activator, which is live currently, where you can contribute to the rootstock ecosystem as a developer, as a writer, the community man or where you can contribute and earn some great rewards. Where you can contribute to the blog post or guide tutorials, technical documentation. You can contribute and you can create the video guides and tutorials, smart contract development tutorials, and so on. So with that, that's all about Rootstock. Let's go ahead and start actually building our smart contract. As I said, the token staking smart contract. Make sure you have installed Foundry, get faucet, and added the Rootstock testnet and mainnet to your MetaMask. So let's get ahead. Let's go ahead and let's create a new folder to our desktop, and let's name it token staking, and open it in our VS Code. Just and let's open up our terminal, and let's initialize the new Foundry project. And let's by running this command forge init. There we go. Our project is initialized, and since we are going to use OpenZeppelin, we are going to create a token staking 20 smart contract. For that, we are going to use OpenZeppelin. So let's install OpenZeppelin by running this command forge install OpenZeppelin /OpenZeppelin contracts, and hit the enter. While it is installing, let's delete these files because we don't need anymore. We are going to create it from scratch, and let's delete this one, and yeah, and let's create a new file. Inside that, let's create a new file, and let's name it what to name. First we will create a ERC20 smart contract. So let's create a staking token dot sol, and you can see our OpenZeppelin contract version 5.3.0 has been installed. And let's clear it and set our remappings to avoid some red and grid lines, which is very annoying to me. So let's first set our remappings. Forge remappings dot txt, and let's start. You can see it, the Foundry automatically generated the remapping.txt file where you can see all the remappings are set. So let's go ahead and start building our staking token contract. It is very simple because we are going to use the ERC20, the Pragma Solidity, SPDX license MID, and let's use the 20 version of Pragma Solidity 0.20, and let's start writing contract staking token, and let's make it up here. Let's make it ERC20. This and as well ownable thanks to Copilot, where this ERC20 is coming from. Let's import it from Foundry. OpenZeppelin. Open import. Let's name. We are going to import named import. There are two types of import thanks to Copilot. So you can see here, I imported ERC20 from OpenZeppelin contract token C20 and ERC20. If you don't know how to create ERC20 smart contract, I already created a video of how to create ERC20 smart contract and test it and deploy it on Rootstock testnet. So make sure go back and watch this as well to get understanding how to create ERC20. So I'm not going to explain it here, but still I'm going basic overview where this ERC20 is coming from. We already installed OpenZeppelin library in our project, and if you go here inside the lib folder, you can find OpenZeppelin contracts, and inside that contract we are importing this from this OpenZeppelin libraries. So that's it. And now let's initialize our constructor, and inside that constructor let's see 20, and let's name it not a staking token, but let's name it a Rootstock infra token. So here Rootstock infra, its symbol should be like say RIF. And now let's make it ownable, and inside that ownable we have to pass message dot sender thanks to Copilot, and there inside that constructor let's call the main function. Again, I'm not going to tell you where this main function is coming from because I already explained in ERC20 smart contract tutorial where all this coming from and how we can build. So in the main function takes two parameters. So first the message dot, and let's say this much, and yeah, to multiply 10, and not decimals, and inside that we have to call this. That's it. Let's format the document, and let's create the function. Let's name it mint function mint, and address to sorry, not address, unt to put the amount, and let's make it public and only owner, because we are inheriting, and there we have to call this mint function, and to and amount we have to pass, and that's it. We created our staking token for our staking contract. So let's try to compile it. By the way, this video will be so long, so I decided to create only contracts in this video, and in next video we will test rigorously every single, we will write comprehensive test for smart contract, where I will explain every single detail of test, how you can test smart contract like professional smart contract developer, and at the end we will deploy this on Rootstock test network. So let's compile this smart contract first for by running this command for build, and you can see here our compiler run successfully, and we successfully build this 20 smart contract for our staking contract without any error. So let's go ahead and create a new file inside the source, and let's name it staking contract, where we will write our main logic staking contract.sol, and let's pragma license identifier MIT pragma solidity 0.8.20, and let's start writing contract. Let's staking contract, and we have to make it secure, and as I said, we will add some advanced functionalities like control possible and like this. So let's start writing staking not token exactly, staking contract is enable, and we also have to make it reentrancy guard. Let's first import what we need from OpenJeplin, or we also need IERC20 OpenJeplin contract slash OpenJeplin slash contracts slash open slash IRC20 the ownable, and the reentrancy guard. We also need the possible, so import possible from OpenJeplin contracts slash utils and possible.sol. That's it. With that, let's copy it from here and add reentrancy guard here. Also, we have to make our smart contract possible. What's this? Callback not supported. It will be fine. It's just a VS Code problem. So let's clear it and make it down. Let's start writing our smart contract. So first, let's declare some state variables. Copy it from here, and let's state variables. Name it IRC20 public, and let's name it staking token. We have to also declare the reward rate and last updated time, reward for token stored, and duration, and the minimum stake, and so on. So let's first declare unt2 reward rate, and that's it, the reward rate, last updated time, the 2256 public, last updated thanks to Copilot. Let's to be more clear, let's name it last updated time, and reward for token stored, it is also be in this public reward per token for suggesting me, and the duration should be in 20 to 56 public duration, and let's initialize duration here. Let's I think let's make it to 165 days, and also the minimum stake, even let's make it capital minimum stake, and let's say 100 multiply 100, and this is the minimum stake amount, let's say 100, and this is the configurable reward duration, right? Let's format this, and what kind of error we are getting. This is just VS Code warning, I think. Don't worry, we also need to declare some mappings. So let's declare mapping address to u/6. I will explain why we are declaring this. These are just state variables, and to track user reward for token paid, we have to declare this mapping. So user reward for token, and we also need to add mapping for rewards and balances. So let's add another mapping. My bad. And again it's address to u/256. Let's make it rewards. Also add let's add another mapping for balances. Copy it from here, paste, and let's name it balances. And another variable we have to add public supply next to copilot. Let's format this. I love formatting to beautify my code. And now let's initialize our constructor here, the constructor, and inside that constructor we are going to take address of our staking token. Okay, so as a parameter address of our, let's say, staking token, we are going to deploy this. Just we created the previously, and here inside that constructor let's initialize the staking token as IERC20 and the staking token, and inside that we have to pass this staking token. And also let's initialize here last updated time, it's equal to, let's say, block dot timestamp, and that's it. Let's format. I don't know why this error are not going. It is just my VS Code problem. If you try to forge build, and what is this going? Importance regard, yeah, I think something I did wrong. Smart open Zeppelin contracts. Let's open Zeppelin slash contracts 20. I think it's just a remapping problem. Let me fix this here. So if you face problem, don't worry, it is just small errors, so we can fix right here. Open Zeppelin, just go to our remappings and make sure it is open Zeppelin slash dash contracts token, not sure. Let's again, let's go back. I don't know why it is happening, but if this is not working like this, then let's comment this out, and we can use like this. Let's copy it from here, and let's say from dash, and that's it. It is just my VS Code problem. We can use like this as well. Now what is the problem? So you can see here the base constructor. think I need to do something. No argument passed to the base. Yeah, this is because we didn't make it ownable here, so make sure you are making ownable here, and inside that ownable let's pass the message dot sender, and the error is gone. That's it. Let's format this. And now what is this error? The Morgan taking contract till I think the VS Code problem. Let's run force build, and you can see here now all the errors are gone, and we successfully cleared. So I just deliberately, or I just wanted to show you how you can save. So this is not the best practice, but for testing you can fix the errors like this. I just wanted to show how you can solve errors right here just by spending some time right here. I just So let's go ahead and create our first function. But before going to create first function, let's create a modifier. Let's name it modifier. I hope you know how modifier works in Solidity. So let's add this modifier of update reward, and inside that we are going to uh, take an argument of the account, of the address of the account. So let's address of the account, and inside that reward for token stored, we have to initialize this reward for token stored as is equal to reward for token. Don't worry, we are going to create this function very soon, and where I will show you how this is the just design of the smart contract. I'm just we can create I have inside my design smart contract how we can create this. We are going to create this function later after. So just to bear with me and I will explain you everything. So last update time we have to insert last update time, or the I think updated last update, I think update last update time we have to initialize here, and this is equal to reward applicable. This is the function we are going to create. If you think it doesn't make sense right now, it's okay, I will explain you again. I will explain you everything. This is the function we are going to create. Last time reward applicable, time reward applicable, and again here we are going to create logic. If account, this account, copy it from here. If account is not equal to address 0, then we are going to set rewards, actually rewards of the account. Remember we declared the mapping here, and here we are going to set amount. This is the function we are going to create. Inside that let's pass an account, and there we go. Now user reward per token paid, we are going to initialize here. Inside that let's pass this account again, copy it from here, account, and reward. Let's set this to reward for token stored, and that's it. Let's close the modifier here. How to close? Like this. Now you will find these are the three errors. These are the three functions we are going to create very soon. I just designed this way and created the modifier first, so I will explain this logic very soon. So let's create our very first and small function. Function last time reward applicable, copy it from here. That's it, public view, and it will return some unt amount, or the block dot time 20 data structure, or the block dot timestamp. So returns 256, where we are going to return here block dot timestamp, and that's it. You can see, let's format, and you can see our one error gone here from here. Last time update, yeah, there is, and now undeclared last update time, and our errors are gone. We will fix errors one by one, don't worry. This error, these are the two errors, this one, and this one. All these errors we will solve, and we will compile our smart contract successfully. Let's go ahead, and from here let's create our second function, reward per token. Copy it from here and create function reward for token. Let's make it public view returns, and from here we gonna return 256. Now let's write logic. If total supply is equal to 0, and then if like this, then we will return reward for token stored, reward for token store, plus from here we have to create last time reward applicable, and we have to call this, and we have to make it minus. Okay. From there last update time, and from here we have to multiply this into reward rate multiply whatever. Let's multiply reward. Let's multiply e. From here we have to divide by total supply, and that's it. This logic will not make sense to you now, but it will make sense. So the enter error, pass error, I think that's gone. We have now remained only 2 errors, and we will solve this very soon. So let's create our next function, function earn. So let's create function earn. Let's make it, let's take an address of the account, and it will return event 256 as well. So let's make it returns event 256, and from here we are going to return let's say balances of our mapping, and from here we have to add count here the inside the balances. And now let's multiply this the token for token, sorry, reward for token, uh, reward for token, and let's call it now minus user reward for token paid, and inside that we have to pass this account, right? And I think I did some mistakes here, not, I guess, right? And now from here we have to divide 1e18, and now make it plus rewards. Inside there's rewards, we have to pass this account rewards and pass the account from here, and that's it. There we go. Or another function is ready. Yeah, now I guess I did some mistakes here. Let me check where yeah, this is here. We have to add this one, and that's it. And let's compile our smart contract, and let's see how it goes. User reward for token ID. Yeah, from here you have to make, I actually it was syntax mistake, and now you can see here our compiler runs successfully again. So this is how you can fix the errors right inside your development environment. You will learn a lot here. So let's make our another function, which is the stake function. So let's make it function stake, and the stake function will take an amount as an argument or the parameter amount, and let's make it external now. And we have to make this function secure, because this is one of the most important function of our smart contract. So let's make it non-reentrant. Also we have to make it when not forced, it is coming from OpenGPLin libraries, and also add to update reward, and inside update reward we have to pass message.sender, and let's write logic here, require, and inside the require the amount should be greater than or is equal to, sorry, greater than, I think we declared here a minimum stake, it will throw an error below minimum stake or something like this. And now let's say total supply is plus or is equal to amount, and now we have to create another we have to declare our mappings here for balance space. Inside that balances we have to add message dot sender, and from here addition plus is equal to amount, right? Now staking token that we declared, that staking token dot transfer from, inside that we have to pass message dot sender and address this and amount. Let's go ahead and emit an event. We are going to create this event staked. How to create, we will declare this, let's wait for some time, and let's pass from here message dot sender and amount, and let's go above, copy this here, and let's go right below the constructor, and let's declare our events here, and inside that event stake we have to pass address. Let's index, because if you build this smart, if you smart contract for front end, it will be very convenient for you to fetch the data. So for that we are going to use indexed. So let's address index and unt 256, which is no need to index right here. And now our function stack is ready. I think what is the problem, my Wi-Fi is connected. Yeah, now we have to create our other withdraw function, get reward function, and after that we have very small functions. So let's create our withdraw function. It is also one of the most important function where we have to build a critical logic, not a function. I'm sorry, it's a function. It is also going to take an amount, unt 256 amount, and let's make it public, non-intent when not faucet, and update reward. We have to copy this everything from here and paste, and here let's write our function body or the logic. We have to pass the required, and inside the required amount should be greater than 0, otherwise it will throw an error, withdraw 0. Now go ahead and create another require statement. The balances of the message.sender is equal to or greater than amount, otherwise it will throw an error, insufficient balance. Right, now let's set total supply. It's equal to minus or is equal to amount, and then the staking token in total supply. We have to also add here balances of the message.sender. We have to minus it from amount as well, right? So let's do this. And now staking token dot transfer. From this transfer we have to pass the message.sender and the amount, and now we have to emit an event. I think we have to copy it from here and now paste an event. Let's say withdrawn with dra, withdrawn, and inside that pass the message.sender and the amount. Copy it from here and paste it here, and that's it. Now we also have to declare this user and amount. Let's go ahead and event with n address indexed user and copy it from entire here and paste it here. That's it. And now we have to create another more important function, that is get reward. Let's go ahead and create a function get reward. Let's make it capital to be more clear, and we are not going to take any parameter here. Let's make it public, non-intent when not fast, and update reward. Let's copy it from here. That's it. Now let's start writing our function logic. For that, let's create a local variable here first. Let's name it reward, and let's set this rewards or rewards to message.sender. And now let's write if reward is less than 0, and then we will create rewards. That's the rewards, copy it from here. Rewards of the message.sender is equal to 0, and staking token dot transfer, and from here we can pass message.sender and the reward, message.sender and the reward. And let's emit event here, reward paid. Let's emit reward paid. Let's make it, and here we have to pass message.sender and reward. Events are very important in your smart contract. If you are professional smart contract developer, make sure you are adding events. What was the name of our event? The reward fade. I think I forgot the reward fade. Copy from here, paste reward fade, address indexed user, and unt 56 amount. Feed of amount, we have to pass reward here, reward, and that's it. Now we are almost ready to finish up, but we have to make to three more small functions that are very small. So let's start continue writing function exit and make it external, and we have to make it not fast, and inside the body let's call the withdraw function here. You can copy it from here, and balances of the message dot sender, and now we have to pass the get reward here. We have to call the get reward function here, and that's it. Let's go ahead and create set reward rate function. Set reward rate, and let's make it external and only owner. External only owner. Before that, we have to set reward, we have to take parameter of event 256 as a reward rate, and only owner. After that, inside that body of the our smart function, we have to set the reward of this reward rate. Actually, yeah, this reward rate, and now set duration function. Set duration, again copy it from here. We have to set duration here. Let's make it external only owner. Copy it from here, and duration, let's set our duration is equal to this duration. Now we have to emit an event here, minimum stake updated, sorry, duration updated, because I forgot to the duration here, sorry. Now let's emit this event duration. That's it. What is this problem? And now let's write our other function. Set minimum stake, set mini stake, and 256 we have to set here, and let's make it external only owner, because we are going to give this all these functions only owner access, and inside that minimum stake is equal to this minimum stake, and from here we have to emit an event minimum stake updated, emit minimum stake updated, and from inside that we have to pass this here and this one. Let's format this document again. I think why it is not formatting. Let's declare this event first. From here, event new duration, and let's name it what I think new minimum stake. And now at the end, what we have to create, we set the our duration, reward rate, and minimum stake. Now let's pause and unpause on these functions. Let's call this function pause and external only owner. Now let's call this pause function that we are importing from OpenJeplin, and also let's unpause function pause. And we almost did our smart contracts. We are about to wrap our smart contract, and let's inside that call on pause, and there we go. And let's try to format, and we will fix all these three errors thing. Yeah, function on there. Let's first format the document by running this forge fmt, and there was the error, parse error, function get reward, run interrupt public. Yeah, there are a lot of bunch of errors because we are adding commas here. My bad, how can I do this? So yeah, to fix these errors you can use these strategies. That's it. Now I again forge fmt. Now what is this? In line number 120, let's clear it again, and we will fix this, clear and forge fmt. From here you can see first 68, line number 68. From here function on account 260, and we are returning balances and account. So multiply reward token and minus user reward token for paid, and account slash 18218 plus rewards, and account. That's already, and I think there's a problem with this is my VS Code problem, I guess, because all the functions we return are the right. Let's try compiling by running forge build, and you can see here there is only one error here. Sol 72. Yeah, if you can see TION, and you can see we are going to format the document, and now our all the ready. There's this is also silly spelling mistake, and let's try compiling a smart contract for by running forge build, and there is one more error: identifier not found or not unique. 32 new duration 32. Yeah, new duration, I think event duration updated, new minimum stake, new duration. What is this problem? Yeah, we didn't give type of new duration. That's crazy. There are a lot of errors we are facing, and we will fix right here. I'm just making this for to show you how you can face errors and how you can resolve this right into your development environment. So let's clear it, and let's first build again and declare a variable message dot. There are again 74 line. There is again error, 74 message dot sender, spelling mistake again. And now let's build again, and you can see here our compiler actions, our compiler run successful. Our smart contract is finally ready to test. There are just these are some my VS Code errors. These are not the real errors. If you see here, our smart contract is successfully built compiling world Solidity files with Solc 8.0.8.30. That is current version of Solidity compiler, and compiler run successfully. You can see here we are trying to compile again forge build and compiling, no file change compilation script, and it is not throwing us any error. So far I will show you what we have done. We initialized the Foundry project, we installed the Open Zeppelin libraries, and we created staking token, that is Rootstock infra token, and we also created the staking contract where we are importing some ERC20 ownable reentrancy and possible contracts from Open Zeppelin, and also here we have declared some state variables, mapping to tracking constructor where we set some values. Here we have some our, that's my again by spelling bad mistake, events, and here we have the modifier. Here is the function for last time reward applicable, and the reward for token, and the function earn. Now you can see all the errors gone. It was just for my because of my VS Code error. So you can see here we have important function like stake and withdraw, get reward, and after that we this edited return the exit function, and the only owner can access this function like set reward rate, set duration, and set minimum stake. And we have also function like pause and unpause that has only access for only owner. So in this video we built smart contract. I know it is already very long video, that's why I didn't plan for the testing. So in the next part of this video we will rigorously test. I will introduce you some of the best Foundry test practices, and we will test our smart contract, and at the end of second part we will deploy it on Rootstock test network. With that, I will see you in next one. Thank you very much for watching. Bye bye.